Hello, this video is covering fraction arithmetic. We're going to be talking about how to add, subtract, multiply, and divide fractions. And the first thing I want to point out to you is that whenever you add or subtract fractions, you must have common denominators, meaning the bottom of the fractions have to be the same. If you have common denominators, then adding and subtracting is really easy. Like in this example, since you're adding 1/5 and 2/5, they're already over 5. All you do is add the numerators. 1 plus 2 equals 3, so we get 3/5. Also keep in mind, any answer you get as a fraction, you always want to reduce it fully. And 3/5 is already reduced in simplest terms, but if it's not, you can factor the top and bottom and cancel any common factors. I'll show you some examples of factoring in just a sec. Here we have an example of adding fractions that do not have common denominators. So the first thing we're going to do is we're going to factor our denominators into prime numbers, what we call a prime factorization. So basically 18, we know 18 is 9 times 2, and we know 9 is 3 times 3. So here we have 3 times 3, which is our 9, and 2. These are prime numbers because they can't be divided further. There's no other way to multiply to 3 other than 3 times 1, for example. So this is what we call the prime factorization of 18. If we do the same thing with 24, 24 is 8 times 3. Here's your 8, 2 times 2 times 2, and there's your 3. So this is still 24. Now, what we're going to do now is if we want a common denominator, we need to balance out our denominators. If you focus on the 2's, for example, this one has 1 2 and this one has 3 2's. So this denominator needs 2 more 2's in order to both have 3 2's. The only way we can do that, though, is if we multiply it on top and bottom to balance it out. So I'm literally going to multiply 2 2's down here and 2 2's up here. Right, so now each denominator has 3 2's. Now we need to do the same thing for the 3's or any other factors. This one has 2 3's, this one has 1, so we're going to need another 3 here and here, top and bottom, times 3 times 3. Right, so now I know that each denominator has 3 2's and 2 3's, so it has a common denominator. I'm going to multiply everything back together. So on top here we have 5 times 2, which is 20. And our common denominator ends up being 8 times 9, which is 72. Right, that's what you get if you multiply the 2's and the 3's all together. And the second fraction becomes 21 over 72. Now we have a common denominator, so you just add across the top and we get 41 over 72. And there is our answer since it doesn't factor further. Right, let's take the same thing down here on this next example. We don't have common denominators, so we're going to start by factoring them. 30 is 5 times 6, and 6 is 2 times 3, so 30 should be 2 times 3 times 5, right, 6 times 5 basically. And 12 is 6 times 2, and 6 is 2 times 3, so 12 is 2 times 2 times 3. That's the prime factorization. Now we need to balance this, so let's start with the 2's. I can see that this side's going to need a 2 on top and bottom, and now each denominator has 2 2's. The 3's are already balanced. Each one already has 1 3, so we don't have to mess with that. But this denominator over here is going to need a 5, since the other one has 1 5. And we have to do it on top and bottom. Right, so now you can see each denominator has 2 2's, a 3, and a 5. If you multiply this all together now, on top we have 34 over, what do we have on bottom? We have 6 times 5, which is 30, 30 times 2, which is 60. That is our common denominator. And then up here we have 25 also over 60. Now we have common denominators, so you subtract across the top and we should get 9 over 60. And actually, since both of those have a 3 in common, if you divide top and bottom by 3, you get 3 over 20, which is your final answer fully simplified. Multiplying and dividing fractions is a little bit easier because you don't need common denominators. For multiplication, you just multiply straight across the top, straight across the bottom to get your answer. And for division, you actually turn your division into multiplication by flipping the second fraction. Right? So A over B stays the same, but C over D becomes D over C. And then you change it to multiplication. Keep in mind, your final answer needs to be simplified, so we're going to do some canceling along the way. In this example, we're multiplying fractions, so the first thing I'm going to do is factor every piece into primes. That includes the denominators and numerators. So 3 is already prime, 8 is 2 times 2 times 2, 4 is 2 times 2, and 9 is 3 times 3. So now you can see everything that all the pieces, numerators and denominators, are made up of. And the whole point of this is we want to cancel everything before we actually multiply things back together. So right now, since we have multiplication, we can do what we call cross-canceling. Basically, any number on top will cancel out with any numbers on bottom. So for example, you can see that we have a 3 on top here and 1 3 on bottom there. Right? I just divided 3 over 3, which is 1, so it went away. I also can cancel 2 2's on top, 2 2's on bottom. So that takes care of all the simplification. And keep in mind, when every time you're canceling out, there's a 1 left over. So even though on top everything canceled out, we actually still have a 1 on top. And on bottom we have a 2 and a 3 left over, and so 2 times 3 is 6. We get 1/6. Right, so that's how you can cross cancel, or basically reduce as you multiply, in order to save you some steps. In this problem, we're dividing a whole number with a fraction, and anytime you do any arithmetic with whole numbers and fractions, you always want to start by making your whole number into a fraction, by putting it over 1. This way they both look like fractions and you can just follow your fraction rules. So for division, our rule is you change it to multiplication and you flip the second fraction. Right, so the second fraction is going to become 4 over 3. And now for multiplication, we'll do what we just did in the last step. We're going to factor 12 into primes. 12 is 2 times 2 times 3, and it's over 1. And we're going to factor the 4 into primes. Oops. Factor the 4 into primes, which is 2 times 2, and 3 is already prime. And now we're going to cancel, cross-cancel anything in common. And it looks like in this case the only thing in common is that 1 3. And so if you multiply everything together, you get 2 times 2 times 2 times 2, which is 16 on top. And on bottom you only have a 1 left over, and anything over 1 is itself, so our final answer is 16.